Hi, I'm Predator. Welcome to my YouTube channel. This is my first Houdini tutorial on how to make the snow growth effect in Houdini. A basic knowledge of VFX coding and VOP is required to understand the video, as I will go through my code really fast. So I will first build 6 lines, which will be our main branch of the hexagon, and then I will scatter point on those lines and put a second hexagon on those points to build our second layer. And later I will also put a third layer, and it will be our initial snowflakes model. So let's go to Houdini, add an empty object, rename it to growth tutorial. So we will be modeling the snowflakes first. So add a line here. And set the length to 10. And the point, I will give it 6 points. And prepare a transform node to rotate the line. So we will use transforms to rotate it 60, 120, 180 degree to build the rest of the lines and merge them together. So it's just a simple modeling process. So I think I will speed up the video here. Now I'm going to give them a normal vector by adding a attribute wrangle. And during my first video recording, I actually used 6 wrangles to 6 branches individually. But later I realized I can just use 1 wrangle and connect it to 6 transform nodes. Here I set the normal to point upwards, so 0, 0, 1, 0. And we also need an up vector, so I set it to 1, 0, 0. These 2 vectors are important in the copy to point node later to make sure our second branch will have a correct orientation. Okay, now just simply connect the output of the attribute wrangle to the transform nodes that we made previously. For visualization, we can add an add node and delete the lines but keep only the points. And don't forget to disable or delete the add node because we don't need it later. We are going to resample the curve. I think the length 0.4 is enough detail. And enable the curve view here below. So the idea is later we are going to use the curve view to separate the points by frames, and this will be our growth effect. To visualize the curve view, we add a color node, and the attribute should be curve view, and we will give it a random color ramp, so pick whatever you like. So to give it a more organic look, we want to deform the point along the normal direction. But we using the mountain node does not give us the desired look, so we cannot control the deformation, especially around the center, where our snow crystal begin to grow. So instead, we will be using a point VOP where we have a full control of the geometry. Okay, let's go inside. And so the idea is we deform the point along the normal. So let's we add the normal to the position, and you can see there's a hole in the center, so we need to bind the curve view attribute, which is 0 at the center. So we need to multiply the normal by curve view. So the further the point is away from the center, the more the point will be pushed away. And then we control the strength by adding another multiply, promote the parameter, and go outside, edit parameter interface, and rename the parameter name so we can understand better. And as you adjust it, you can see the outer point get pushed away more, while the center point stays in its place. So to bring more shape variation, we will use the prenom attribute because we have 6 lines here. One line counts as one primitive, so we have 6 different primitive numbers here. Connect the prenom to the random node here. And let's organize it a little bit. Now multiply the normal by the output of the random node. So let's go outside, and you can see as we adjust the strength, the snowflakes begin to take some random shape. And I always forget to change the parameter name here. Okay, so to have a more control, I decide to add a constant number to the multiply, to the normal, for more parameter. Edit parameter interface, change the parameter name to offset, and change the range. So now we have a slider to control the overall scale of the snowflakes. So to make it more organic, we can also randomize the distance between each point. So this is done by adding a noise to the curve view attribute and promote parameter, the amplitude and frequency. So now add it to our curve view, and you should be seeing some variation. So let's go outside and adjust it. Here you can see. Set the range. Okay, so one problem here you see in the center. The point will be crossing to the other direction, which we don't really want. To solve this problem, we can also use curve view again as a fall off to the noise, because curve view is 0 at the center. And you can see. Now the point shall not cross to the other side. And now we don't like the random node here because it does not let us control the seed parameter. So now I will add the random BRJ here, where we can promote the parameter, the seed, and we have more variations this way. So now I'm going to rename all of my nodes, because when I come back to my node tree later, I can better understand what I have done before, and I can make changes more quickly. So this is a good habit. So I will just speed up here. You just finished your first branch here, and now we are going to make the growth effect. Add a new node here, and we want to give it a parameter, a global control of our time scale. Add a float number, we call it like timer. So we will use this frame information to control our growth. So here add the $FF here. So the idea is each frame we pick the point which is a curve view within an interval, and then we shift the interval each frame. So since the growth starts from the center, we will pick those points which has the smallest curve view. So we will type this in a group expression. Add curve view smaller than, and copy the parameter, paste it here in a expression, and add a group name, pick time. Let's check. Wait, yes, we need to set the group type to point, and still not working. Yeah, let's divide the time by like 20 and see my old code here. Yes. Yes, now it's working. Okay, we add a second group expression here. Just copy it and change the sign here, and we will need to add a minus 0.05 in the end, and select it to merge operation intersect with existing. And now you can see, now every single point only appear in one frame, so we have a good time separation. So now let's add a simple solver. Go inside the solver. So how a solver works is that it stores the geometry from the previous frame, from the old frames, and also grab the new geometry from the current frame. So in our case, we just have to merge the old and new points. So just add a merge node here. And I also forget to add a blast node to delete the unwanted point. Only keep the points that we pick up. So this double group expression coupled with solver will give us the best growth effect, the control we need. And now add a copy to point. We will give it a shape. So add a sphere. And set the type to polygon, frequency to 2, and now this is the most basic growth in Houdini. So here I'm just going to use my old code here. So the idea is for each incoming point, we initialize the age and set the initial p scale and give it a growth speed which depends on the curve view. So the closer the point is to the center, the faster it will grow. So the trick here is the factor 1 minus curve view. And for the geometry from the previous frame, I just check for every point with age larger than 0, I increment the p scale with the growth speed. So basically it's like a pop solver. Yes, so now we see like a starfish. And now we can go back to our point vault and change to adjust the shape to whatever you like. And here I just break up the points, and you can see it gets more organic. Okay, so now we will just use these nodes later, and we need to Now we want to make our second branch. So first add a copy to point. And basically what we are doing here, we just grab the side branches, the 4 branches, because the up and the down branch will be overlapping with our first branch, so we don't need them. Now merge them together like this, and Alt click to create a node, so it's better to organize your node tree. So you see the orientation is a little bit messed up. So we just add the transform to our secondary branches, make it smaller, and rotate it like, let's try 90. Yes, now it's working. So now we need to add some scale variation to our second branch. So now we want to introduce some variations in the P scale. So we will just add an attribute wrangle here. And I will just grab my old code. Yes, so now I will just copy my old code here. So basically what I'm doing here is I make the P scale depend on the curve view and also a random factor from the point number. So I have a global strength and the remapping from the curve view, and the third factor is the random factor with a minimum 0.2. So now in the channel ramp, we can add some variations to the shape, and don't forget to increase the strength here. So here I noticed a problem that when P scale is 0, the orientation gets messed up. So one way to fix is by adding a group expression and a blast node to delete points with P scale is 0. So now I will be working on the shape of the second branch here. So now change it, increase the scale, and add some variation so the tip should be smaller. And we can also go back to our point bulb to adjust the shape. Yes, basically you can make it like more snowflakes like, or more organic, more chaotic. So now we add a resample node and set the length to 0.4, and now enable the curve view and rename it to curve view 2. So this is important because this is basically a second layer of growth, which we will use it later. What we are going to do next is simple. We just copy our first branch, the first nodes here. So add a frame, rename it to layer 1, and copy this node tree and pass it here, and replace the resample node here, and we name it layer 2. So this is our second branch. And in the color we change it to curve view 2. Here in the point bulb you see something is not right because the bind node we need to change the curve view to curve view 2. And the amplitude of noise is also working. So in this attribute wrangle, where we will be setting up the P scale of our third branch, we don't need too much detail, so we just make everything simple here. So now we want to make the third layer, which is simple. We just copy it again. And don't forget to add a copy to point node here. Now just grab our branch here and connect it to the resample. And again, you can go to this wrangle node to adjust its shape. So now I just decrease the scale, the global scale of the branch. Also rename the variable name curveview to curveview2. So now we have modeled our snowflakes like 3 layer branches. Now we want to merge them together. So we will just grab the node here and resample it. So in this resample node, don't enable the curve view because we don't want to override the old curve view attribute. And add a group node because we need to identify which point belong to which branch. So I will rename it to B1, branch 1, branch 2, and branch 3, and add some random color. So you can also press D to open the display option of Houdini and set the background to black so you can better see your geometry. And now don't forget to change the group to point group. And you can also visualize it by the add node. So now you can go back anytime to adjust the shape of the snowflakes here. And now branch 3, yes, I forgot to change the curve view. And because this is very small, so we don't need much variation, so we will just bypass the point bulb. And we also don't need the nodes for the P scale because we don't need the forward branch. Here we add a wrangle, and the trick here is to sum up our curve view attributes to a global curve view so we can like control them together. So global curve view equals curve view plus curve view 2 and curve view 3. Yes. Now connect it to the node here we made previously. Yes, just copy the curve view global here. Okay, so now it should work now. So you can see this very interesting firecracker effect. So I hope you find it useful, that you can use it elsewhere, not just in this snowflakes tutorial. And to visualize better, I will just make it white. And to control the growth time, multiplying curve view with a factor to slow it down. So here we added the factor to our curve view, so the main branch will grow slower. So this is a trick. And now I will just grab our old code, the solver. So basically how it works is simple. So the idea is simple. I just blast the other 2 branches. So I separate the branch 1, branch 2, and branch 3. And of course, you can use split node instead. And then I'll just give them a different growth parameter, different P scale and growth speed. So branch 1 and branch 2 will have a growth speed depend on the curve view, while in branch 3 I keep it simple, so all the points have a constant growth speed. And then I just propagate it as usual. And in the geometry spreadsheet, you can check how the parameter changes, how the attribute changes, and of course, feel free to change the parameter to experiment different conditions. So now the initial sphere is too large, so we set the scale to 0.2. So my Houdini viewport began to struggle now, so we need to optimize a little bit. So the way to do it is by adding a fuse node. So I just add a fuse just below the solver and only apply it on the branch 3, so B3 group. So now it should work. Because we have the group information, right, which point belongs to which branch, we can separate the branches and use a different copy to point node to give them a different geometry, to give them a different shape. So for example, I want branch 1 and branch 2 to be sharp, so I will just use a sphere, while for branch 3, I want it to be flat. So the sphere for the branch 1 will have a scale of 0.15. So for the branch 2, we don't need too much detail. Frequency is set to 1. And for the third branch, this is the trick. We'll use a circle with a flat surface, flat top and bottom, because later the snowflakes will have a reflective flat surface, right? So now add the poly extrude and copy parameter and paste here, and we need to divide it by 2. No, minus 0.5. Multiply by minus 0.5. Yeah. So this will make it symmetric. So now output back. Okay, so we are almost there, but there are still some improvements that we can do. And by the way, there is an option on the bottom left, the global animation options, and you can change playback method to play every frame or skip frames, but keep it real time. And now you can change the shading to smooth shaded. So here you can also check individual branches in the copy to point node. So now we go to branch 3 and change the resample length. Yes, much better. We also don't need this resample node. And add a fuse node here. You see in the center it's just too messy. And it will slow down if we have too much geometry, so I'll just add the 0.08. And then we can also go back to our branch 1 to control the shape. After you are satisfied with the shape, you can add the VDB from polygon and convert it into a single VDB volume. And the voxel size of 0.05 should be enough. And now we want to add the VDB reshape SDF here and expand it a little bit. So you can also try to shrink it a little bit, depending on what look you are aiming for. Now we convert VDB back to a single polygon. The idea is the same as you do the flip sim. So you are using the particle fluid surface, right? But now, using these VDB nodes, we have more control over what we want. And you can adjust the look, how much detail you want on your geometry. Here I think the surface is too rough, so I'm just going to use VDB smooth and decrease the strength and some slight adjustment. So now we want to optimize the geometry. So in the convert VDB, so now we can reduce the complexity of the geometry. So let's go to the convert VDB and adjust the adaptivity parameter. And we'll be going back and forth between a smooth shaded and smooth wire shaded to check the surface. And adjust the adaptivity again to keep the detail. Now we can save it to disk or export it as Alembic and to the Blender and render it out. But you can use whatever renderer you like Redshift. So after I finish the video and render everything out, I realized that realistic snowflakes is actually a little bit different. So as you see in the image, the branching is only in the forward direction and not backward, as in my case. But personally, I find my version with a backward branching more interesting looking, like a more aggressive growth. So if you want to make it realistic, it is easy. Just go back to Houdini and delete the backward 2 branches. And you are good to go. You can check the final result. Congratulations, you just finished the snowflakes tutorial. And in the next part, I'm going to talk about how I grow snowflakes on the custom curve. If you are interested, you can stay. Okay, so you can draw your custom curve here. Give it a normal along the direction of the curve. So here's the trick. You have to enable the tangent U in your resample node and type the vex code here. I basically use a double cross product. So I will not explain too much the math behind it, and I will also not explain too much about the vex. So just to show you the trick here. And then I just connect it to our main branch here. And it's simple. It just works this way. And basically we are done. So thank you for watching. So this is my first tutorial and my English is also not perfect, but I hope you enjoy the video. And I will provide the scene file, HIP file in the description so you can check later. So thank you for watching. Bye.